Let's talk about the laws of algebra sets. Now, there are several laws that you need to understand if you are to understand sets, okay? Basically, there are about 8 of them, and we're going to talk about all of them one by one. Let's start with the first one. This is called the idempotent laws. Now, this term is to mean that once you start with a letter, it will still give you the same letter, okay? So the first idempotent law that you are supposed to know is A union A. It's just the same as A. You're able to see that we started with A and we've ended with A, okay? Then the second idempotent law that you need to understand is A intersection A will still give you A. Okay, now let's explain these two. Let's start with the first one. So we're saying A union A. Let me explain this in form of a Venn diagram. Okay, let's say this is our set A. Now, union, you're just combining what is in A and probably another set. Now, we're combining what is in A and what is in A. So, what are you going to get? So, if you combine what is in A with what is in A, you're just still going to get A. So, that is the first expression. Then, let's talk about the second expression. A intersection A. Let's say this is A. Then want to intersect it with A. What is common between what is A? What is common between U and U? It will still be U, right? Or what is common between A and A? It will still be A. So this is one of the laws that you need to understand if you are to understand sets. Then the second law that you need to understand, now this is very important, the associative laws. Okay, now if I ask a question, if I added 1 plus 2, I put this in bracket, plus 3, is it going to give me the same answer if I added 1 plus 2 plus 3 and I put that in bracket? Provided the sign doesn't change and it's unique throughout and all the numbers, the arrangement doesn't change, but what has changed is of what we're adding first. Am I going to get the same answer? Let's try out. 1 plus 2, that is just a 3, right? Plus 3. Okay. On the other side, I've got a 1 plus 2 plus 3, that is a 5. Now let's add on both sides. On my left hand side, 3 plus 3, that is a 6, is equals to 1 plus 5 on the other side. On my right hand side is also a 6. Now we're able to see that both sides are giving us the same answer. So that is about the associative law. Now what are these associative laws? Okay, so the first one is A union B union C should give you A union B union C. The second one is, now everything wherever there is union, you're just putting intersection. Okay, A intersection B intersection C is equals to A intersection B intersection C. So these are the two associative laws that you need to understand. Now, for illustration's sake, we're just going, let's solve the first one. The second one will not solve it. You can prove it. Okay, so let's solve the first one. What does this mean? Now, you remember that if you are dealing with union is just the same as or, right? And if you're dealing with intersection is just the same as and. Okay, then on the other hand, union is just the same as like multiplying. Then intersection is just the same as like you are adding. Okay, so let's just do that. So if we say A union B, A is equals to the other side, so which one are we going to prove? Let's use the same one. We see if it is going to give us that. Now I'm not going to use numbers, I'm going to use the same letters to prove. Okay, so we're going to let x be a member of this same set. Okay, this same set, the set we're saying is A union okay, B union C. Okay, why are we letting x? Because a set has members, right? So we're just assuming that x is a member of this set. So now let's try to prove. So the way we're going to do is we're going to separate the union. We said the union is just the same as O, right? So let's just do that. So we're going to say x will be a member of A. Wherever there's union, we are putting O, right? So we're going to put O here. O. Then the same x again will be a member of B, right? Then wherever there's union, we're putting what? O. Okay. Then the same x again will be a member of C. Now, what do we do now? Let's factorize this part. Okay. So what is common? You are able to see that x is a member of is common, right? Okay. So we're going to write x is a member of. That is what is common. Then what remains is A, O. Then we said O is just the same as union. So we're going to say union B, right? Then we bring down our O. This is O. X is a member of C. Okay, now what do? We can, if you want, we can factorize the x is a member of again because it's common on both sides. So what are we going to have? You're going to have x is a member of the A union B. You're going to put it in brackets because it's together. Okay, then you're remaining with, or you're just remaining with this O and your C. So what are you going to do? The O is just the same as union, then C. So now you are able to see that this answer that we found is just the same as on our right hand side. Therefore, we've proven the associative law. Okay, so the other way around, you can also use the other way around. You can also use this one to give you the other part. It's still the same thing. Okay, then you can try out for the one with the intersection. It's going to give you the same answer. Okay, so that is very important for you to understand. Third law that you need to understand is the commutative laws. Okay, so there are also two. Allow me to just write the first one. Okay, let me just write all of them. So we've got A. So if you say A union B, according to the commutative laws, it's going to be B union A. Then the second commutative law is A intersection B is just the same as B intersection A. Now this is just it's not complicated. We're not going to prove it actually. So it's just like plus and multiplication. If I say, because we said the union is just the same as multiplication, right? So if I say 1 multiplied by 2, is it the same as 2 multiplied by 1? Okay, then the intersection we say is just the same as plus. If I say 1 plus 2, will it give us the same answer if we say 2 plus 1? So we're just alternating the two. So we're able to see that the multiplication operation and the addition operation, they are commutative. Commutative to mean even if you change, provided the numbers are the same and the operation is the same on both sides, you are going to get the same answer. So that's about the commutative law. Now let's talk about another law that you need to understand. There's what is called the distributive. Okay, the distributive laws. Okay, so according to the distributive laws, the first one is, if you say A union B intersection C, this is just the same as A union B intersection A union C. Just a reminder, okay? If I'm multiplying 2, okay, let's go back to our primary. If I'm multiplying 2 and I want to distribute these 2 in this expression, let's say I'm multiplying 2 to, let me say this is B plus a C. So what am I going to get? I'm going to multiply 2 by B, right? And I'll write that. So 2 multiplied by B, that is just a 2B. Then again, I'm going to multiply the 2 multiplied by the C, right? So what am I going to get? I'm going to get plus 2C. What I've just done, I've distributed the 2. So that's about this law. So this, just assume that it is a 2 and it's multiplying with B and C that is in the bracket. So when you do the multiplication, you're going to realize that the A, the one that you're multiplying, when it multiplies with the B, that's why you're getting this expression. Then the same A, when it multiplies with the C, you're getting the other expression. Okay, then there's an intersection between them, and that is the intersection. So that's the distributive law in terms of sets. Okay, very simple, right? So now let's solve and let's prove this just using the same expression that we have. So again, we're going to we can just choose maybe X being a member of this set. Let's say X is a member of A union B intersection C. So I'm going to use the left hand side to give us the right hand side. So let's do that. So we're going to distribute the X. Okay, so you're going to say X will be a member of, firstly X will be a member of A, right? Then what did we say when you have union? We said union is just the same as O, right? So you put your O. Then X will be, because there are 2 sets here, so you're going to say X is a member of B intersection C. Okay, yes, there are 2 sets, this set and the other set. Now let's again distribute this further. So we're going to say X is a member of A, or X is a member of, now X will be a member of B and X will be a member of C, right? Because there are 2. So we're going to say X is a member of B. Now there is an intersection. An intersection, what did we say? It's just the same as and, right? Then again, like, you're going to say X is a member of C. Okay. Now here is the tricky part. When you are supposed now to distribute this now completely, you remember that in this expression we had the 2a, or a 2 in that regard representing a 2 was representing, like in this case it's representing like our A. Okay, now this 2 appears on both sides. It also appears here. So X is a member of A will apply like double. That's what I mean, if you're going to distribute it completely. So hope you are getting the sense. So even in this expression, I'm going to write it fully now. X is a member of A, so X is a member of A, or X is a member of B, and X is a member of C, or X is a member of A. Then what do? What you're just going to do now, you're going to put these, you factorize. Okay, So I'm going to say X is a member of there is A has remained, O has remained, and the B has remained when I factorize on this side. So I'm going to remain with A. Our O we said is just the same as union, so then there's a B. This is one set. Now we've got AND here, and we said just the same as what? Intersection. Okay, then you've got X is a member of as being common, so you're going to say X is a member of, okay, X is a member of C union A, or A in A union C, whichever way. Okay, why? Because times or multiplication is also commutative. Whether I say C union A or A union C, you are going to still get the same answer. So now that's the expression. So this X is a member of, if you want you can cancel it, it still give you now the same expression that is on top. Okay, so that's how you prove the distributive laws. So the other distributive law is wherever there is union, you're going to be replacing by intersection throughout. Okay, no intersection, then here there is union. The union here will be intersection, this one will be union, this one will be intersection. So that will be the other distributive law. Okay, then let's talk about the other types of laws that you need to understand. Now these are quite a lot, but you still need to understand. There are about 4 of them. Okay, so these ones are called identity laws. Okay, so even just the name itself, I think it's self-explanatory. So about the identity laws, let's start with the first one. If we say A union empty set, okay, what are you going to have? So what are you going to say? If you combine A, because union is just combining two sets, right? If you combine A with nothing, an empty set, what are you going to have? Okay, or let me say if you combine nothing with something, what are you going to get? You're going to get something, right? So we're going to get A. Okay, so this is our answer. Then another identity law that you need to understand, if we say A intersection intersection empty set, what are you going to have? Now what is common between A and nothing? Here now we're not combining, but we're trying to find what is found in nothing and in A. Okay, so you're going to realize that nothing is common between nothing and something. There's nothing common, so you're just going to get an empty set. So this is another thing that you need to understand. Then another identity law that you need to understand is A union universal set. Okay, let me put a big U to represent the universal set, or let me put an E to represent our universal set. Now the universal set is just like everything in the universe. Picture it that way. Now what is common between A and the universal set? What I mean is, if you are going to combine, because the universal set is the bigger set, the universe in this case, picture it that way, then in that universe there is a set called A. Now if you combine what is in the universal set and what is in A, what are you going to have? You're just going to have the universal set. Okay, so you're going to get the universal set, or E. Okay, so that is also another important law that you need to understand. Okay, then what other law can we put? If we say D, if we say A intersection U or intersection E, what? So So even this one is just a guess. You're able to see that what is now common, what are you going to find between, or what is common between the universal set itself and A, or what is found in both. If this is the universal set and this is A, so what is found between the universal set, or what is common between the universal set and A, it will just be the A itself. Okay, so that is very important for you to know. Then probably we can also manipulate which one? This one. Let's make it this as E, another one, where we say A union empty set. Okay, so if you combine an empty set and A, what are you going to have? If you combine A, every time you combine a set with nothing, you're going to get the same set, which is A. Then another key thing that you need to understand is every time you combine a small set with a bigger set, you always get the bigger set. Okay, every time you combine a small set with a bigger set, you always get the bigger set. That's just common sense. Okay, so those are the identity laws. Then you also need to understand what we call the complement laws. Okay, now what are these complement laws? Now you know that when we're introducing this topic, we said there are two types of complements in terms of set operations. Set operations, we said you have the union, you have the intersection, which I'll just write like that. Then you also have the complement. Now the complement itself, there are two. You can have a relative complement and an absolute complement. Now a relative complement is one that is not it's not a full complement. If I say A minus B, and if I say A complement, okay, this is very different. Why? Because if I go for the absolute complement, it means I don't want anything that is not in A. Or what I mean is, we want everything that is not in A. Okay, pardon me for that one. So you want everything that is not in A. That's A complement, right? And then A minus B, you want what is in A, or how can I say, A minus B is just the same as A intersection B complement. You want what is in A, but you don't want what is in B. Okay, so those are the complements that you need to know. Now with this case, the complement laws that you need to understand is let's start with the first one. If you are given A union A complement, what are you going to get? Okay, so let me explain this using a Venn diagram. Okay, so if this is A, then let's say this is A, then this is our A. Then what would be A complement? A complement would be what, everything that is not found in A, right? So everything that is not found in A is this, and this is what we are saying this is A complement. So now there is a union. You're combining what is in A and what is in A complement. So what are you going to get? You're able to see that what you're going to get is just the universal set, the whole set. Okay, the universal set, which let me denote it as U. So that's the set that you need to understand. Then another complement law that you need to understand is, if we say A intersection A complement, what are you going to get? Okay, what is common between A and its complement? Okay, the same analogy, this is A, and A complement will be everything outside A. Now what is common between the two? So you're able to see that there is nothing that is common, so the answer will be an empty set. Okay, or what is common between what is inside something and what and something that is outside? It's totally nothing, right? Okay, so that is important for you to understand. Then the third law that you need to understand is, if you've got A, there's a complement and there's a complement outside. Okay, what this will give you is you're just going to get A. Okay, why? Because the complement and the complement will cancel. Okay, so let's put it into context. So if we're going to draw a diagram like that, okay, which I'll use our Venn diagram. This is our A. If that is our A, then let's write A complement. What would be A complement? A complement would be what is not found in A, like that. Okay, then that is our A comp. So this is our A complement. Now from this A complement, then there's another complement, meaning now we want what is not in A complement. Okay, so we found our A complement to be that. Now we want what is not in A complement. So we're able to see that what is not in A complement is this that is in the middle, which and that expression, or what we've just highlighted, is our A. So that is the law that you need to understand as well. Then another law that you need to understand is the universal set complement. Okay, so what is outside the universe? Or let me say what is outside the heaven and the earth, maybe to make it simpler. Okay, don't say it's space, because space is in the heavens, it's in the atmosphere. So what is outside the universe, or what is outside the universal set? There's nothing, right? So this is an empty set. Then the last one that you need to understand here is let's say the complement of an empty set. Okay, the complement of an empty set. Okay, so the complement is now an empty set that it has nothing, right? But now you're trying to find what is not in an empty set. Okay, so that would be just the universal set, right? Or what is outside nothing? What is outside nothing is something, and that something is what? The universal set. Okay, let me put it into the diagram. Allow me to draw here. This is our universal set. Okay, this is our universal. Then nothing is everything that is outside the universal set. Okay, now we're saying what, because if this is nothing, then we're trying to find the complement of nothing. Now the complement of nothing, it means everything that is not found in nothing. Everything that is not found in nothing is you're able to see that this part that I've shaded is what is not found in nothing. So find that will just be your the universal set. So that is very important for you to understand. Law number 6 that you need to understand. Okay, this is a very simple one, and I've been talking about it. This one is called the difference law. Now the difference law, if we say A minus B, it's just the same as A intersection B complement. Let's draw a diagram to put it into context. Okay, if this is our A and this is our B, okay, if this is A and this is B, if we say A minus B, it means we only want what is in A, and we just want what is in A minus B. Okay, so that will be the expression. Okay, then or how can you put it? A you shade and B complement you shade. So I've written two expressions. Okay, let's see if the next expression I've put on the other side is going to give us the same answer. This is our A, this is our B. Okay, and this is our universal set. So if I'm going to shade what is in A, which is this, let me shade that. So what is in A is this, and what is here in the middle. Then let's shade what is in B complement, what is not found in B. Okay, what is not found in B will be this. Now the question I'll ask you is, what is common or what is found in both A and B complement? What is found in both? So you're able to see that what you're able to find in both is just this part. Just this part. Okay, and that part is just the part of A, okay, and you are removing B. So that is what is called the difference laws. Then let's talk about one of the most important laws that you need to understand. Now if you understand this one, then I would have done I would have done justice for this topic. This one you have to know. It's a must, okay? It's a must know. There's what is called the De Morgan's laws or the De Morgan's laws. Now these ones, I repeat, it's a must. You need to. If you've been sleeping, this one, no. You just have to be active. So if we say A union B complement, it is just the same as A complement intersection B complement. Or if I say A intersection B, there's a complement outside, it's just the same as A complement union B complement. So these are called the De Morgan's laws. Okay, so you're going to encounter a lot of questions, whether in a test, in your exams and whatever. Most of the questions will be based on the De Morgan's laws, the distributive laws and the associative laws, maybe even some commutative laws, but this one is a must. You have to know. Okay, so let's try to prove the first one. Okay, so let me use the same letters. Let X be a member of, let's say X be a member of, let's start with let's use the same left hand side, okay, and to give us the right hand side. So let's say X is a member of the first set, which is A union B. Then there's a complement. So what are you going to do now? Let me manipulate this. If X is a member of A union B complement, meaning X is not a member of A union B. Is that the same? This is just the opposite of this expression. Okay, what I've just changed is one, X was a member of a complement. If X is a member of a complement, meaning X is not a member of what is found in that set. Okay, so that's what I've just written. Okay, hope we are good on this one. Now if X is not in A and not B, so let's say if we're going to distribute this, because this is now the distributive law, but you're going to distribute, so you're going to say X is a member of A. What did we say our U is? Our U said it is, alright. Or now, because these ones are combined, or if you want you can put and. Okay, X is a member, actually this is just one set. So okay, they were combined. So and X is a member of B. Now, oh, it's not a member actually, because it's not a member, so that's what you're going to write even here. If X is not a member of A, what is X going to be then? Meaning X will be a member of what? X will be a member of A complement, right? Hope we are good. And X will be a member of what? B complement, right? Yes. So if X is not is not in A and B, X must be the complement of both, right? So I am saying X is a member of A complement and X is a member of B complement. Okay. So now how do you do that? Now you just factorize, okay? So you're going to say this will just be the same as, I'm going to factorize the X is a member, so X is a member of A complement, and it's just the same as intersection, then you have your B complement, okay? Or you can leave out the X is a member and you just say X complement intersection B complement. Okay, good. So that's what you need to understand. Then let me just make it clear here. Here I've put and. Why? Because we are putting the opposite. Actually, this was supposed to be here. This one was supposed to be an intersection. Okay. Why? Because I've done the opposite. The opposite of X is a member of A union B complement. It is X is not a member of A intersection B complement. That's why I've put the and I've gone with the and throughout. I thought of clarifying that. Then after you've proved that, all your provings, at least as a student, once you're done proving, hence proved, to show them that you've proved that the left hand side is equals to the right hand side. So this is how you understand, and these are the important laws that you need to understand on sets, and would solve questions, and there'll be a mixture of these laws and you'll be able to understand them. So in the next session, I'll be talking about sets of numbers. Thank you.